All right, we're live. Austin, in favor. No more back and
Thank the Lord you said that.
no more. Okay. I'm just gonna put this in the here and now. My father-in-law's brother was in Vietnam.
My grandpa was in Vietnam.
So was mine.
Okay, please let me finish. Just please, okay? If you want to talk about this more later, we can. Let me finish my point, and then we got work to do. Okay? There were a lot of people that fought in Vietnam. Your grandfather being one of them. My wife's uncle being my wife's uncle being another. My father had a really high draft number, and he actually never had to go over to Vietnam because he decided with his high draft number to go into the National Guard. They weren't taking National Guard people over at the time. There were a lot of young men that were extremely scared. They were put into a rough situation where they didn't know the territory, and they didn't know when they were over there who was a friend and who was a foe. A lot of them got exposed to Agent Orange. A lot of them have had experiences they'll never forget that were very tragic and sick. My wife's uncle refuses to even own a gun to this day because of it, and has never fired a gun since Vietnam. It's a sick and tragic experience for a lot of them. Okay, and for someone, especially knowing that in terms of Vietnam, to say, especially if you're saying that around them, so I'm just trying to curb right now, it's probably not the greatest thing to say, especially if you run into someone from there, that they're going to take offense to that because you have no idea what their experience was like. Okay, so you want to say that in other classes, that's fine. It's no longer acceptable in my class. Capiche? Thank you. So, iron 2 oxide plus aluminum yields iron plus aluminum oxide. First thing you got to do is, like I mentioned, if the equation, if they give it to you as a word equation, of course you've got to write out the actual chemicals in the equation, then you have to balance it just like we've done before. 2 irons, 2 irons, 2 aluminums, 2 aluminums, everything, the other 2 should be 1 and 1, 3 oxygens for each one of them. Okay, so just like before, we're ready to roll there. Okay. Step 1. And I'll start by saying if the problem gives you grams, then you're going to have to do this step. But if not, you can skip to step 2. So this is only if the problem gives you grams, which most of them will, but some of them may not. The question says if we react 150 grams of Fe2O3 and 60 grams of aluminum, which one will be used up first? So our first step is to convert both grams of aluminum and grams of Fe2O3 into moles. So we have 150 grams of Fe2O3 and 60 grams of aluminum. Okay, so to get them to moles, we're going to have to take and divide them by their molar mass, again, which is the amount of grams in 1 mole. So 1 mole. Okay, for aluminum, aluminum has a molar mass of approximately 27 grams. Iron 2 oxide, we're going to have to add up the mass of 2 irons plus 3 oxygens. 16 would be 1 oxygen, so 16 times 3 is 48. Iron, Fe, I never quite remember what's that. 55.847 times 2. It says 159.69. We'll call it 159.7. I'm going to add that to 48. Okay, so altogether, when I add 2 irons plus 3 oxygens, I get 207.7 grams. That is the molar mass of 1 mole of iron oxide. Again, it had nothing to do with the number out in front. All I did was I added up 2 irons plus 3 oxygens, okay? And then the same thing for aluminum. I did not do 2 aluminums because the chemical itself is just aluminum. You use the small numbers in figuring out the molar mass. The big number is simply for balancing the equations, and then of course for the BCA table. So these numbers out in front do not figure into the molar mass. Okay, so 60 divided by 27 is 2.22 moles repeating. For iron oxide, 150 divided by 207.7 gives me 0.722 moles of Fe2O3. So now I can set up my BCA table. Now in these limiting reactant problems, we're no longer just going to be able to use that term excess in reference to the before for the reactants, because we actually now have numbers of both of them. Yes, one of them will be the excessive reactant, but now we actually have physical numbers for both of them. For iron 2 oxide, 0.722 moles is what we had. For aluminum, 2.22. And of course for the products, unless specified, 0. So now, step 2. Here's where it gets interesting. Now that we have moles of both of our reactants, what you're going to have to do is pick one of them. And it doesn't matter which one. Pick one. And convert it to moles of the other. So 0.722 is what I'm going to pick. So I'm picking 0.722 moles of Fe2O3, and I'm going to convert it to moles of aluminum. Yes, ma'am?
The other thing where I can see.
Yeah, let me hand it to, you get it up here? Awesome. There you go. You betcha. Okay, so 0.722 moles of Fe2O3. Now I've got to use my ratios to turn it into moles of the other. So I want to get it to moles of aluminum, so that means I'm going to have to take 0.722 times 2 to get moles of aluminum. So 2 moles of aluminum divided by 1 mole Fe2O3. Cross out moles of aluminum. So I'm taking 0.722 times 2. And I get 1.44. Okay? So, what I just did by doing that step is I just figured out which one is my limiting reactant and which one of my reactants is in excess. Okay, so step 2, the pick one, this is all about finding limiting and excess reactants. Okay, so 0.722 moles of aluminum. If I use up all 0.722 moles, I'm sorry, not aluminum. If I use up all 0.722 moles of Fe2O3, that means I'm going to use 1.44 moles of aluminum. And according to my BCA table, do I have at least 1.44 moles of aluminum? Yes, I do. So that means that Fe2O3 is limiting, and that aluminum is my excess. Okay. Now, if I would have gone the other way, let's say if I picked aluminum first, then I would find that I would have needed more than 0.722 of Fe2O3. I would have needed more. But obviously I only have that amount, so then I would have had to have gone back and have done this step to figure out how many moles of aluminum are going to be used up. So I use 1.44 moles of aluminum then. And I use up all of my 0.722. Okay. So I just want to stop at that moment and ask so far. Questions up to this point? And out of curiosity, would you like me to do that other step of showing if I would have used 2.22, how many moles of iron 2 oxide I would have needed? Would anyone like to see that step out of curiosity? No? Okay. So then, in terms of then the after, we know we're going to have 0 of this. Let's see, 1, this would be 0, of course, and this would be 7, 8. I think that's right. Yeah, 11 minus 4 is 7, 12 minus 4 is 8. So I would have 0.78 moles of aluminum remaining. Now I've got to finish completing my BCA table to find out how many moles of iron and aluminum oxide I'm going to gain. Plus, plus. Okay. Now the process becomes a lot easier because I can use my ratios that I have in here that are the same as one another to finish filling it out. Iron and aluminum are the same, so whatever I lose of aluminum, I gain of iron, 1.44. Aluminum oxide and iron 2 oxide are the same. Whatever I lose of iron 2 oxide, I gain of aluminum oxide. Okay. Now I've completed the table. Now I can go on and answer the question. The question then says, the question then asks, how many grams of iron are going to be formed out of all this? All right, so step 3, complete BCA table. Okay, so we did that. We completed the BCA table. Step 4, convert moles back to grams. And step 4 is one of those, again, if it's necessary. The problem may just ask for moles. So if the problem just asks for moles, you're done. But if the problem asks for grams, you're going to have to do step 4 then. Okay, so then, according to what we have here, it asks for how much iron was going to be formed. Well, we've got 1.44 moles of iron. So step 4 then, 1.44 moles of Fe. I'm going to multiply by grams over 1 mole. So I'm multiplying 1.44 moles of iron by its molar mass. Iron was 55.847. So 1.44 times 55.847 gives me approximately 80.4 grams of Fe. Now I've just answered my question. Okay, so from that process, questions? So that's ultimately what doing limiting reactant is all about. You're just first trying to figure out how many moles of each that you have. Step 2 is figuring out which one is your limiting reactant, which one is your excessive reactant. So then you take moles of one of them and figure out, if I use up all of that reactant, how many moles of my other reactant are going to be needed. And if you just happen to pick the right one, you'll find out that the one you picked was the limiting reactant, and then the number of the other would end up being less than what is there. Obviously, if not, then that just means go to the other one and do your math to find out how many moles you would need of it. Any other questions, or would anyone like another example, or are you ready to try it on your own? I mean, whichever. How about this? Show of hands. How many would like another example? A few of you? Any? Okay, a couple of you. Tell you what I'll do. I'll do one other example. So make sure you got this example down, and I will be happy to do one more example. For those of you that are ready to move on and do enough and to try worksheet 3, go ahead and get started on that. Or also, if you needed to borrow this sheet, which it's got my writing on it here for the blurred sides of the pages. Because I know that when I copied it, I couldn't quite get the book all spread out perfectly so that it would catch everything. So if you had any trouble reading that and you'd like to see this, or if you'd like to see my book, I'd be happy to do that as well. Yeah.
When are journals due?
Journals, well, you guys, it's not going to be due for a little while yet because we still have the other lab yet to do. The other group, or I'm sorry, not the other group, my 2 seniors, well, I think what I'm going to have them do, 3, Becca, Kenzie, Gabby. What I'm going to have you guys do is just do the current, obviously the lab write-up for the current lab that you had to do, the one with the copper silver nitrate. I'll just have you turn that one in, because obviously we're probably not going to get to the other one in time for you to have sufficient time to write your journal. Okay. So I think that's the route that we're going to have to go between you and Becca and Mackenzie. We're definitely going to need to be rocking on the assignments. I will share the rest of the assignments with you in the unit, I think, this weekend. So be on the lookout for that. But obviously, I don't want you to get alarmed. The only reason I'm doing it will be for Gabby, Becca, and Mackenzie, my 3 seniors that'll be graduating. So that way you've got all the assignments that you can work on and practice on, and meaning that you'll have to test by the end of next week then. That you'll have to finish up your tests, that way I can get grades done and grades in. Which, if I remember right, when is your guys' last day? Is it next Friday? Okay, so it's a week from this coming Monday. Okay. So that'll mean that you'll need to have your test finished by the end of next Friday in order to get all that accomplished. Okay? So, otherwise, like I said, if you wanted to go ahead and work on worksheet 3, you can go ahead. I'll work on another example up here just so that you have it. I'll record the example while I'm at it too. Let's see. All right. So another example is what you wanted for some of you. So another example you shall receive. Okay. Let's go ahead and erase this one. By the way, for those that need, I think I had this up the other day, but in case you didn't get it, for those that needed to do the problems, And again, if anyone wants to practice these, they can, to help each other out. If you have the assignment, these are the problems. Yeah, Ryan?
Does anyone need a stapler?
Does anyone need the stapler?
Anyone?
Okay.
It's great even
All right, so another example, and like I said, obviously you're free to work. For those that want to pay attention to the example, be my guest. If not, just please be quiet and working then. So the second example that I have for you would be the reaction of nitrogen gas and hydrogen gas in order to make ammonia. So N2 plus H2 yields NH3. I'll get the phone in just a moment. Helen. Good, what's up? Do I have to clear mine here? Yes, I do.
Uh-oh.
Like how quick? Well, tell you what, how about this? Claire, do you have a moment to talk to Mr. Mahachek?
Sure.
All right, well, one moment. Yep.
Okay, we'll
Go get your paper from the library. Okay, so the Haber process is what this is called to make ammonia. You have nitrogen gas. No, Claire, back over here.
Oh my goodness me.
Phone. He's on the phone.
Japers.
So anyway, nitrogen gas plus hydrogen gas, I get NH3. You gotta balance it, of course. Okay, so 2 and 3. Do you need to go down for anything? Or? Okay. So 2, 3, and just 1 here. So we're balanced. 1 nitrogen gas, 3 hydrogen gases yields 2 ammonia molecules. Okay, so from the question, we have that we're reacting 100 grams of nitrogen gas with 10 grams of hydrogen gas. So we got 100 grams of N2 gas and 10 grams of H2. Okay, so 100 grams of N2, 1 nitrogen atom is 14, so 2 nitrogen atoms would be 28. 1 hydrogen atom is 1 gram, 2 hydrogen atoms would be 2 grams. So pretty simply put then, 10 divided by 2 is going to be 5 moles of H2. Okay, 100 divided by 28, not quite so easy. We should come out a little under 4. 100 divided by 25 would be 4, but 100 divided by 28 is going to be a touch less. So 100 divided by 28, I get 3.57. So 3.57 moles of N2. So those are my before. So N2, 3.57 moles. H2, 5 moles. Just to emphasize that the BCA table is the use of moles, not grams. 0 of NH3. So now I need to then determine which one is going to be my limiting reactant. And I think I've got a feeling already that I know which one it's going to be. Anyone want to take a pick at which one they think is going to be the limiting reactant?
Gonna say it's the H2.
Yeah, it's definitely going to be the H2. Because even as I think of this, if this were a 2-to-1 ratio, 5 divided by 2 would be 2.5. We're going to have to divide this by 3 to get N2. So it's only going to be, I think it's going to be something like 1 2/3. So we'll only need 1 2/3 moles of N2 altogether. So again, 5 moles of H2 times 1 mole of N2 for every 3 moles of H2. So 5 divided by 3, yeah, I know 5 divided by 3 gives you green leaves.
Unless
Maybe
you're a
so you can make some
4-year-old.
peppermint tea, I guess, right? Huh?
Unless you're a 4-year-old, then it's 3.
Yeah, there you go. So 5 divided by 3 gives you 1.67 moles of N2. Okay. So 1.67. So minus 1.67. And the reason I'm doing this already, as you can see, obviously, we've got plenty of moles of N2. So that means all 5 are going to get used up of the hydrogen gas. And we're going to have leftover nitrogen gas. So excess limiting. You don't have to do this on yours. I'm just doing it as demonstration for you guys. So now, in terms of here then, we have 2 moles of H3 for every 1 of N2, so that means we're going to need to take this and multiply by 2. So 1.67 times 2 it'd be 3.33 repeating ultimately. In other words, 1 2/3 times 2 is going to end up being 3 1/3. So 3.33 moles. So 3.33, 0, and this would be, let's see, 1.90. Okay. The problem that it asked me is we're trying to determine the amount of NH3 that's being formed. So we want to find out in terms of grams how many moles of NH3 are being formed. Okay, so then for NH3, here's the amount of moles. I want to convert it then to grams. Okay. So 1N plus 3 hydrogens. So N is 14 plus 3 is 17. And we had 3.33 moles NH3 times 17 grams per 1 mole. And I get 56.6 grams. 56.6 grams of NH3 that I'd formed. 56.6 grams of ammonia. Alright, I wasn't planning on any more examples, but other questions that come up as to anything that I did or why or the balanced reaction, anything, thoughts? It's okay if you don't have any questions, but okay. If not, obviously you got a few minutes to work. Monday will be solidly a work day, of course. I will check on the progress of this assignment for those that need it. I'll also check on the progress of worksheet 3, the limiting reactant worksheet. And also I will check on the progress of empirical formula. My plan was to have this due on Tuesday, 5/6. Okay, so you can be working on that for Tuesday. My plan is to get that all done by Tuesday, and then we're going to do a lab that is involving our silver that we made from the previous lab. Okay, so you should obviously all have your information from the previous lab for how much silver you actually created. So we'll need that information in doing the next lab. So, all right, I'm going to shut the video off.
Yeah.